I'm an architect, originally from Scotland. Been in Kenya for the last 13 years, working with my company BuildX for the last 5 or 6. And we are architects, engineers, and building contractors working to particularly lower the embodied carbon footprint of our buildings. Globally, around the world, our population is growing rapidly. So much so that we have an incredible demand for new buildings, new schools, new hospitals, new housing. The extent of demand forecast over the next 40 years means that we will add to the planet the equivalent of New York City or Paris every single week. That's a construction rate that we're already building at today. So this is not some big statistic that's been forecast for the future. We're already doing it and will continue to do it for the next 40 years. What is changing, however, is where that new construction is taking place. Over the last centuries, as we've moved away from rural areas increasingly and built cities, most of the construction has taken place in areas that you wouldn't be surprised by. China, North America, Europe are the top 3 on the left in the yellow there. And that's the amount of floor area that currently exists on our planet today. But if we look at the next 40 years on the right-hand side of the center line, we can see where the future construction is going to take place. And about 35% of all of that new construction will take place here on the African continent, particularly in the years between 2040 and 2060. You think cities like Nairobi are growing quickly today? Wait until 20 years' time. Now, this is a problem because buildings and construction account for almost 40% of global carbon emissions. And this is made up in 2 parts. It's made up of operating emissions, how we heat, cool, power our buildings. But it's also made up of embodied carbon, the carbon that's associated with the materials and the construction methods that we use to build. And of these, concrete and steel are the biggest culprits of all. They account for about 8% of global carbon emissions, which is about a quarter of the built environment's footprint overall. Concrete is actually the most consumed material in the world after water, which is quite a shocking way to think about it. And of course, most cities are made from these 2 materials. Look around you, it's mostly concrete and steel. And so as we increasingly urbanize our population over the coming years at a rate that's already very fast, we're going to see an increasing use of these materials unless something changes. And so at BuildX, we follow what we call a 3R approach to building. And this starts first with reuse, which is to say, let's only build new where we have to. If we can reuse existing buildings, repurpose buildings, building is inherently a carbon-emitting act. And so if we can do something to not emit that carbon, let's do it. But the reality is that such is our growth, we need to build a lot more new buildings, as I previously showed. And so when we do that, there's 2 other strategies we can apply. First, to reduce the amount of material we use. So let's forget for a minute how bad or good that material is. If we can simply use less of it, there's immediately less carbon. And so building leaner structures, investing more time into design and innovative engineering to reduce those volumes, being less wasteful in the construction process. About 30% of the material from every construction site leaves that site as waste or lost material, which is a huge volume of our industry, which is accounted for carbon, but is not actually used in the final product. But ultimately, we believe we also need to replace the materials that we use today. This is a graph that I'm sure many of you will be very familiar with, which shows the movement of atmospheric carbon to terrestrial carbon, or the other way around in recent times over millennia past. And so we can see that millennia ago, a lot of atmospheric carbon was sequestered into the ground through things like forestry and other sequestration methods. And as we've relied on mineral-based and extractive construction materials like concrete and steel, that carbon has been released back out into the atmosphere. And so this is a trend that we know from the climate emergency and challenges related to that we need to reverse. And buildings have a major role to play in that, particularly through the use of bio-based materials like bamboo and wood. And so today I mainly want to talk about wood, and I want to talk about wood in the context of buildings of the future. Where do we go now? So this is something that I'm sure many of you will be familiar with, but we talk a lot about this 3S model of sink, store, and substitute. When we plant trees, those trees sequester carbon. The carbon remains stored in those trees when we harvest them, and if we can use that timber in building products, which are really one of the longest lasting physical products or materials that we can produce with timber, decades if not centuries, we can lock away that carbon for a very long time. But we can also have the net effect of offsetting or not using the carbon that we would have emitted by using concrete or steel. On average, a cubic meter of wood stores roughly 1 ton of carbon. Doesn't matter what form that timber product comes in. And if we made 90% of all of our new buildings from wood, we could cut global emissions by 4%. Now that's more than the carbon footprint of flying. But in the media, how much have you heard about flying versus buildings? Certainly the former, I would have thought. Which is not to say that flying is not something we should do less of, but certainly we need to focus on buildings as well. And so the graph that's shown here shows concrete, steel, and timber, and it shows how much carbon on average per ton is emitted versus sequestered. And as you can see, the amount emitted for concrete and steel, particularly steel, is significant versus the amount sequestered, which in the case of steel is nothing. In the case of wood, there's a significant amount more sequestered in that process than there is emitted to produce a wood product for buildings. And so the net effect is a negative one in a climate positive sense. So we're sequestering more than we emit. But specifically, I want to talk about mass timber. And mass timber is a new or relatively new form of wood product. It was mentioned briefly in the last presentation as cross-laminated timber or glue-laminated beams. And this originated as a technology in Austria and Germany about 20, 30 years ago in the 1990s. And since then, it's particularly over the last few years, it's experienced a rapid rise in interest, in popularity, in new information and evidence to support the use of this building material. And essentially what it is it's taking young, fast-growing agroforestry species, particularly things like spruce, fir, pine, even eucalyptus now, and gluing it together either in parallel or in cross directionally in each layer to create large, massive pieces of wood that can be used for structural purposes in buildings. So much so that today in Chicago, they're planning an 80-story building constructed using this material. No concrete, no steel above ground floor, all wood. It's incredible. Now, at this point, most people, at least in many of the places I taught, look at me like I'm a bit odd, and they sort of think 80 stories made out of wood. Surely fire is a major concern. Well, the interesting thing is that actually fire is the one of the things that's really exciting about this particular product and material. Firstly, if you were to try to take a large piece of wood, any kind of wood, a big log or a big piece of CLT, and try and get it to go on fire with a match or a lighter or a blowtorch, you're going to be there for a very long time. In fact, you're probably unlikely to get that piece of wood on fire. When it does go on fire, which you'll do by burning lots of small pieces to build a big fire, and you let that fire burn until it goes out, you'll find that log still in your fireplace, even in your home or wherever it is you're trying this. But you'll find that log is still there. It hasn't disappeared. It hasn't burnt to nothing. If you cut through it, you'll find a perfectly preserved piece of wood in the middle and the char layer, which has obviously suffocated the oxygen and stopped the fire. And the great thing about this is that wood burns incredibly predictably, unlike steel, which melts, and concrete, which explodes in a fire. And so engineers can predict to the millimeter exactly when that fire will stop and how much wood will be preserved in the middle. Meaning that if we're in buildings that made from this material that go up in fire, we can feel confident that the engineers know exactly how much wood to leave to keep that building standing. So that 80-story building, you'd rather be on the 80th floor in a timber building than one made out of concrete or steel. The other thing that often comes up is that cutting trees is bad. And here I'm sure I'm talking to the converted, but of course cutting the wrong trees can be very bad for the environment. But cutting the right trees and investing in sustainable forestry with the right safeguards can be an incredible natural climate solution to sequester more carbon. The big challenge for us in East Africa is looking at where is that supply going to come from, and can we resource and supply a sustainable wood building market at this scale with the forest potential in the region. And so we know that in Uganda, for example, we have a surplus of wood relative to local demand coming online by 2030. We also know that in Kenya, on the right here, that business as usual suggests that we have a major problem with demand exceeding supply, but that there is potential through unlocking more investment into forestry, reforestation, and so on, to increase that supply level. There was recent research carried out by the London School of Economics, published earlier this year, which ranks countries or regions according to their potential for a mass timber building industry. And that measures the potential based on demand for new buildings, the health of the forestry environment and the amount of supply, as well as the infrastructure to move timber of this scale around. Sweden, perhaps unsurprisingly, scores #1 in the world on that research. But what might surprise you is that when you take East Africa as a region, particularly Kenya and Uganda together, it would be in the top 5 in the world. So the potential here at that level of study, at least, is very compelling. There are other challenges, of course, that I'll get into shortly. But just quickly to finish up on the benefits, and particularly from a building perspective, this product, cross-laminated timber or glue-laminated beams, they're 80% lighter than concrete for construction. And so that means we can have much less material in the building and much lighter foundations that require less material. They can be up to 70% faster to construct. And that makes a huge difference both in terms of meeting the new building demand, but also for developers or other building owners in terms of their finance and their ability to meet their client needs more quickly. The material is also more thermally efficient, creating a better internal environment for occupants. It's stronger pound for pound than concrete and steel, so we can actually make stronger buildings. And the one that really excites me is that it has proven health benefits. Timber buildings have been shown now through research and evidence, particularly in Europe and the US, where there's more of these buildings to see, to reduce stress levels, to help purify indoor air quality, and to overall have a positive impact on occupant health. I'm excited to say that BuildX, in partnership with a CLT panel processor in South Africa called XLAM, as well as various other partners, including Gatsby Africa, who are here today with us, have been able to build the first CLT prototype in East Africa. So this is at Tatu City. You can go and see it today. We have our launch event next week, so if anybody's interested, please reach out. And it's essentially conceived as a simple prototype exhibition to begin to give people a sense of what this material feels like, what it looks like, what it's like to touch, and has information inside in the form of an exhibition so that you can learn more about it. Personally, I love the look of the exposed timber, but what's also great is that if you don't need to see that timber. You can create an apartment that looks exactly like any other concrete or steel apartment you might walk into. And actually, we've been deliberately sort of tricking people with this. When you approach this prototype and when you walk into this first space, unless you already knew, you have no idea that it's wood. And we've asked developers, construction professionals, financiers, all sorts of visitors to this prototype what they think it's made from when they come in. nobody so far has guessed that it's wood. So it's a very exciting material from that perspective. Just to briefly touch on cost, we've modeled what we think would be the first year's price per cubic meter of CLT if it was produced in Kenya. And so on this basis, we reckon that we can be relatively competitive with the middle income market or middle spec market within Kenya, which is basically looking at a range of between about 45,000 and 65,000 Kenya shillings a square meter. Within that range, we can build buildings that are fairly close, perhaps slightly on the upper side, but there are opportunities to bring that price down. Where we're struggling to begin with would be on the affordable end of the market, where we still have a little way to go to really unlock this material for low-income affordable housing. But we've seen it happen in other parts of the world and in other markets. And so with economies of scale, as well as greater innovation around how we build with this product, we can reduce that price to become competitive over the first sort of 5-10 years or so. Just to finish, the other big barrier that we see is really one of social and cultural acceptance. There's a lot of bias about wood. There's a lot of myths associated with it, be it related to fire, be it related to strength, and so on. So it's not as yet a highly desirable product, at least not here in East Africa just yet. But if you take the building on the left here, this is a building in Chicago. It's just over 10 stories. It was the first skyscraper defined as being a building over 10 stories to have ever been built in the world. It was built in mid-1880s. At the time that this was built, people of Chicago and America were petrified to go inside this building. They thought it would fall on their heads. And within a number of years, we were building structures much taller, including things like the Eiffel Tower, through to today, where we're building incredibly tall buildings, particularly in areas like Dubai and the Middle East and so on, using these materials. People are not scared to go inside anywhere in the world. And so the same can and will happen with products like mass timber. Here we have buildings in Norway and Sweden in the middle and on the right that are already fairly tall, made out of mass timber, and I mentioned one even taller that's in planning. So it will change, it can change. I'm hoping that people in the forestry industry will be the first to buy timber houses made from this product, of course. But briefly, and to conclude really, on our strategy as BuildX, we're working across the value chain now. We recognize that whilst we are architects and construction professionals and building buildings is where we will ultimately be involved, we need to talk to the forestry industry. We need to talk to the wood processing industry. And we need to get all of those stakeholders and partners to talk with each other. And we also need to talk to other private sector players, developers, and so on, and the public environment, be that general public or the public sector in terms of government, to unlock an enabling environment for this product. So just to show the last slide here, really, which is a system that we've developed using this product. We're now trying to move from that prototype into the first mass timber buildings to be built here in Kenya that will be permanent and fairly large-scale buildings. So we're hoping within the next 2 to 3 years that there'll be a significant CLT structure that you'll be able to come and visit. And perhaps Nairobi might look something like this. Thank you very much.